this problem, we want to find the absolute extreme values of f of x is equal to sine of 5x on this interval. So the strategy is you make a table of values for your function sine of 5x. What we'll do is we'll check both endpoints of the interval, so negative pi over 6 and pi over 5, as well as any critical points. There might be a few, maybe there's just one, but the idea is between the endpoints and the critical points, you're going to have a largest and smallest value that appears in this column. The smallest value is going to be the absolute min, and the largest value is going to be the location of the absolute max. I included a graph of this function so we can actually see what we're looking for. I'm going to draw the location of this interval along this axis here. So that is negative pi over 6 is, it's like roughly right here. Pi over 5 is, I think, right about there. So what we're really asking for is, if you focus on just this part of the graph has a largest y value and a smallest y value. The largest one is the max, and the smallest one is the min. So I can see already that this does not happen at either of the endpoints. So it must occur at one of two critical values. So, here I'm going to have a critical value. Here I'll have another, and one's going to give me my min, and the other will give me my max. The way you find the critical values is you take the derivative of the given function and you set it equal to 0. So let's do that for this equation. All right, we have that f of x is equal to sine of, I'll put parentheses, 5x. We're going to take the derivative. The derivative of sine is cosine, and then we copy down the 5x, but by the chain rule, you multiply by 5. I'm going to take this expression, my derivative, cosine of 5x times 5, and I'm going to set it equal to 0 because this will allow me to find the critical values. This equation doesn't look too bad, to start with. You can make it more simple by, if you divide both sides by 5, they cancel here. 5 into 0 just leaves it at 0. So this is cosine of 5x is equal to 0. If we can solve this equation, it'll give us these critical points that we can put here on our table to figure out the absolute max and the absolute min. So that is all we need to do to solve this question. What we're going to do is solve this equation to find these critical values. So let's solve cosine of 5x is equal to 0. There must be two solutions because there are two critical values. Above here, I have a graph of just cosine of x, and I'm going to use this as a guide so I can find the solutions to this equation. The point is, you need to know when cosine equals 0. I mean, it's not exactly cosine of 5x, but again, these numbers will be helpful for us. If you look at this graph, well, here's a spot where cosine is 0, negative 3 pi over 2. Another one would be negative pi over 2, pi over 2, and 3 pi over 2. Basically, just keep counting by multiples of 2 pi from these points to eventually get every single solution. So pi over 2 is the number that you put in place of cosine to make it equal to 0. If you are instead calling the function cosine of 5x, what you're going to do is take 5x and set that equal to, let's say, pi over 2. I mean, this is essentially saying you're putting pi over 2 in place of cosine, but via this equation, we can solve for x. If I divide both sides by 5, it'll go right here. 5 times 2 is 10. And here's a potential critical value, pi over 10. Let's see. You could do the same thing for this 3 pi over 2. You could let 5x equal 3 pi over 2, and we'll see what value we get. I think solving all of these will be almost identical. You'll divide 5 to the other side of your equation. It'll multiply to give me 10. So maybe we have x is equal to 3 pi over 10. Maybe we could use this value. So that would be, we're going to let 5x equal negative pi over 2. Again, solving this for x, I'm going to divide 5 to the side, giving me 10 in the denominator. So x is going to be equal to negative pi over 10. The goal to this is we want to choose critical values that fall within the range negative pi over 6 to pi over 5. And we're looking for exactly 2. Well, pi over 10 meets this criteria. It is within this interval. Same thing goes for negative pi over 10. That's in the interval too. We just found 2 separate values that fall within this interval that are critical values for the original function. They make the derivative equal 0. Here we got 3 pi over 10, but this actually falls outside of this interval, so we would not include this one, so I wouldn't want that. So these are the 2 that we'd like to include in our table. So going back to our table of values, what we're doing is we're putting the endpoints of the interval into the original function, but to my list, I'm going to add the critical values of negative pi over 10 and pi over 10. Whatever the outputs are, when these values go into my function, there's going to be a largest and a smallest. The largest is the max, and the smallest is the min. So I'm going to do this entirely within my calculator. Okay, I just entered them all. For negative pi over 6, I get negative 0.5. For pi over 5, my y value is 0. At negative pi over 10, I get negative 1. And for pi over 10, I get positive 1. So I have my answer. We did see it off of the graph, but this thing is going to be the absolute min because it has the smallest y value. This is going to be the absolute max because it has the largest. And these occur at the x values, negative pi over 10 and pi over 10.